All right, I'm going to show you how to use an online airfoil simulator, and then also how to take data from that and to put it into Excel and then eventually into Inventor. And what we're going to do is we're going to create a 3D model of your airplane wing, and then once we get our wind tunnel in, then we'll test those, and you'll get a chance to compare the data from actual testing and what we would call empirical testing with the data that you calculated or found using the foil simulator online. And this is the kind of thing that we do in engineering all the time. We calculate different values and estimate what we think in theory would happen, and then we check it with actual experimentation. So the three things that you're going to need to open would be Inventor and Excel, and then a web browser. And Chrome is my favorite. It usually works the best with most of the applications that we use. The address you're going to want to go to is www.grc.nasa.gov, and then slash capital www, another slash, and then small letters K-12 slash airplane slash foil3.html, and you can see that address here. Or alternatively, if you wanted to, you could just do a Google search for NASA Foil Sim 3. See, I've already searched for it here once, and comes up with the same thing. There's a couple of earlier versions if you don't like those, but what you have here is you see I have looks like an airplane wing, and I can change different characteristics of it. Notice if I play with this in the screen here, I've got different things I can get going. I can freeze the streamlines if I want. We've talked about these. These streamlines are actually the airflow over it, and we mentioned this last time and how it compresses beneath and it speeds up above. And eventually, as I get away from the wing, the lines are less and less disturbed. They're less moving. If I change my wing shape, you can tell it a little bit. I can change the different things that I'm looking at here. Like I said, I can go to the geometry, and we'll talk about mean camber line and chord line and so forth. We can do streamlines. It kind of shows the things. It's most fun to watch it while it's moving. All right, then I have different buttons over here in this area that I could work with, and I can change various things. I can change it to flight characteristics, and that's going to change down here. It changes what I can do. So I can change my speed. Right now I have one that's moving at 100 miles per hour at an altitude of 0 feet. And I can either put in the altitude. Let's say I want to go to 10,000 feet. I can move that up and see what happens. And I might want to move my speed up to, say, 400 miles per hour. Nope, it didn't like that. It's only going to let me go 250, probably because of my wing. Now the other thing you'll notice, we're going to look down here at this section for the graph. And the graph, it all disappeared when I changed my altitude. And you can click on the rescale button, and it brings that back in play for you. And then let me go back to shape here, because that's the one I'm going to change. And I can also change the size, and this is one of the things you're going to want to do. Change the size of your airfoil and see how that works. But we'll deal with the shape for a moment. Notice the two graphs. The yellow line is the pressure on the lower part of the airfoil, and the violet line or purple is the pressure on the upper part. And this is a good situation. I have a high pressure on the lower part of the wing and a low pressure rather on the upper part of the wing, creating that lift that we've talked about. And it is calculating how much lift, how much drag, and the lift to drag ratio, which is a number we want to be as high as possible. And I can start playing with things like the angle of attack. That's what this is, and I can change that, or I could enter the value if you want, and I can see how that works. See if the angle of attack is 0. This one has virtually the same pressure on the upper and lower, so there's no lift being generated. There's 0 pounds of lift being generated. I change that just a little bit, and I can also use the buttons to change it slightly. Okay, I can create that difference that I want. Make it a little bit more than that. The other thing you can do is you can change the shape. Let's see. I can go with the camber, and I can go positive value and see how I change the curves, the pressure curves above and below. Or I could make it a negative camber. Now here's a situation that's kind of interesting, because I've generated something, if you look at my free stream pressures, where the upper pressure is higher than the lower pressure. And I'm not going to say why, but that just seems like a difficult or a bad situation for an airplane wing. And if you think about the reasons for that, it might tell you something about why no one ever builds airplane wings that are shaped like this. You might also find the answer to that in looking at the flow stream. If you look at the streamlines again, and what's happening and where the velocity is moving the fastest versus where it's moving the slowest. So what you're going to do is you're going to play with all of the values that you have available to you in this website. And you can change the angle of attack even a little bit. We're going to measure it at a number of different angles of attack. But actually, I probably didn't want to camber it that much. Let's go back a little bit less. And if you want to change the size and shape, you can do that as well. But get different values. What you're going to do is to try to generate the largest lift to drag ratio that you can. That's what you want. That's an efficient airplane wing, is if I have a lot of lift and a little bit of drag, and we can't totally avoid drag unless we completely stop. And so you're going to have some of that, but you want to maximize the lift to drag ratio. And you're free to play around with some of these others as well. Let's see, if I go to geometry, that's going to give me something different there. Go back to graph, data or plot, excuse me, go back to plot. So you can do that. Now we will test it at a number of different angles, angles of attack when we get into the wind tunnel. So that's what you're going to want to do here. You may want to start testing at 0 degrees angle of attack, and see, even there with this wing, I've generated some lower pressure and some upper low pressure areas. So even at a 0 degree angle of attack with the camber that I've got, I've actually created a wing that would lift if it were headed straight into the wind, directly into the wind. And then we can change that to, let's say, 5 degrees angle of attack. We could change it to 10 degrees. You can put those in, and I'm just putting them in and entering. And find the different lift to drag ratios, the lift force and the drag force and the lift to drag ratio. You're going to want to record those for everything up until we get to a reasonable amount. Going up to 20, and you start seeing the graph starts looking funny. I don't know if I rescaled if it'll change anything. Nope, it didn't. All right. But you start to see things start to fail, because we're going to hit that stall eventually. We'll hit a spot. It won't let me go past 25. And so what we'll do is we'll compare the values that we get on the wind tunnel with the values that you're getting from the foil simulator here. And you can look at negative angles of attack. I'm not sure if we'll be able to do that. We should be able to do that in the wind tunnel. But of course, you notice here again, I've created a lower pressure region higher than the upper pressure region. So even though this is angled downwards, I'm still getting a little bit of lift. My lift ratio is pretty small. And then if I keep going for negative, taking this way, you see those go that way. And now again, I get the bad situation. So it's possible to use your airplane wing to force the aircraft down if that was needed, if that was necessary. But generally speaking, you'd like to have a situation, something a little more like this. Now what you're going to do once you get the design that's desirable to you is click on the Geometry tab, and you have a lot of data in here. And we will look at this. And actually you want to make sure you get the last data generated, because it's generating that data in there every time we go through that. So I'm trying to see if I can select this carefully. And I'll show you. So we start with Joukowsky Airfoil. And I'm just going to copy that. So I'm going to right click and copy, or Control-C, whatever you like to do. And then I can go to Excel. A couple of these things I'm going to say are recommendations. Some of them are actually requirements. But I would recommend that you start on Sheet 2. The reason is when we import this into Inventor in a minute, it's going to look at Sheet 1. And we're going to actually massage the data. So I'm going to put this in here. And you'll look, and here's my data from the airfoil. And then the one thing that you'll notice is that despite what we put in the size, if you change the size on the airfoil simulator, doesn't matter what you do, the x coordinates always run from about negative 0.5 up to around a positive 0.1 or 0.5. And so we're going to have to scale this data to make it work. And what we're going to do is we're going to import some x and y coordinates into Inventor so that we could actually create our airfoil. So I'm going to go over here and I'm going to take and I'm going to say these are my x coordinates. Actually, I'll put a capital X and I'll put a capital Y. They don't have to be. And then I need to do a formula to play with this data because I don't want my airfoil, it's going to take that in an Inventor in inches. So I don't want an airfoil that's only an inch, one direction. So I'm going to look at this, I'm going to scale it. And what I'm going to do is I'm going to take it and I'm going to say equal sign, which is a formula, and I'm going to say take my x value and I'm going to scale it up twice. So it would be roughly an inch from front to back, as it is right now, from negative a half inch to positive a half inch. And if I scale it up, I'm going to scale it up by a factor of 2 to make it about 2 inches. So I'm going to say that. I'm going to say A10 times 2 and enter. And then I can click and drag, click on the little box right there and drag that over, and that actually scales my Y values as well. And I'm going to drag this down, and I'm going to grab everything. And so now what I have in these two columns right here is my scaled data, and I'm going to need to use that. So I'm going to take that and I'm going to copy it. That's what needs to go into sheet 1. So I'll paste that in sheet 1. And there it is. Oops. There's a mistake. See, I pasted and I get all these references because if you look at it, it actually pasted the formula and I don't have a cell A1 ahead of this. And so what I need to do is actually say paste special, and I want to paste the data. I don't want to paste, or values rather. I don't want to paste the formulas or anything else. Now there's a couple other things we need to do to this to smooth this out. One is right in here, if you look at where that was in sheet 2, it's the lower surface. This is separated into the upper surface and the lower surface, and so I'm going to need to look at that. And the other one is, and so I won't need that row, and I'm going to get rid of it in a moment, but I'll wait. The other thing is, what I want this to do is to be a series of points that goes around my airfoil in sequential order. Right now, this starts at the front of the airfoil, and it works its way around the top surface to the back, and then it starts over again in line 22 at the front of the airfoil. Notice the same x value, negative 1.024, and it starts over again at the front of the airfoil and then goes through the lower surface. In order to make this a continuous loop, I need to reverse one of the other two of these, and because of the way I'm going to use this, I'm actually going to reverse the order of the first set of data, the upper surface, so that it's going to begin at the back, at the point of my airfoil. And I'm going to start it there, so I'm going to say there, and I want to go to data, and I can just click on A to Z because my highlight, or my cell that's highlighted here is in the X column. I'm going to sort it by the X column. I don't want to go from smallest to largest. That's what it already is. I actually would like to go largest to smallest. And so now if I ignore this value line in here and get rid of line 21, which again you'll need to do, I go from 0.994 in the X direction across the upper surface, and then I get to the end of it at negative 1.024, and then I start over again on the lower surface and I move around that way. There's a couple things that are kind of odd here that I'm seeing. One is I got a repeated value, which you want to look for those and try to delete those. Also, if you have any that are just extremely close together, like these right in here, that 0.992 could cause a problem when we go to do the 3D printing. So you want to try to scan any of those out if it doesn't have a pretty significant change. The other one is, it actually starts out here and it's kind of going negative, and then it goes up and goes positive. I'm thinking that's going to create an issue when I put my data into Inventor. I'm probably going to leave it for now, but I kind of want to look at that because I shouldn't have any negative values on the upper surface of the wing. They should all be on the lower surface of the wing. It almost looks like they've kind of reversed here, but they're extremely small values. So you know what, I think I'm going to go ahead and do that. I'm going to get rid of these that are a little bit off because they're going to create some weird surfaces on my airfoil when I do this. So now I have my data. I've cleaned it up. The way to get it in Inventor is I want to save this. And I'm going to save it just wherever, it doesn't matter. And I'm going to call this Foil Sim. And then I'm going to run over to Inventor. And if you're not familiar with Inventor or need a refresher, let's get that taken care of elsewhere. I'll do another video for that. but I'm going to create a new part. I've already created a new part here, and I've done that. I need to create a sketch. Now this Inventor looks a little different even from the ones that those of you that have had this before are used to. I'm going to create a sketch. It actually shows me the 3 planes I could sketch on. Which one you pick is just determined by which way you want your aircraft wing to be oriented. I want it to look like it's flying, so I'm going to pick the XY plane, and that way it's going to look like it's oriented the correct way horizontally. And in order to put in the points, first of all, I'm going to click over here in the insert region, and I'm going to click on points and see the XL logo. And if I change this around to my documents, which might take me a little bit, there we go. And let me sort them by date. So foil sim data rises to the top, and voila, my foil sim data has been pulled in. You can kind of see it looks like my wing is, and I've got some other issues around here where these kind of run together. So I may actually delete a few more of these back here. My wing gets very, very thin near the end, and that would be a problem, especially when I do the 3D print. The last step would be I want to pick the spline tool, and the spline tool is going to want me to pick the different points, and I'm just going to go around the circle. I'm going to pick each one of them. And you got to make sure that there's a green dot. And notice, see my airfoil is going to look funny on this one. I'll fix it in a moment. Now we'll go all the way around each of the points. Okay. And I want to close this. So you need to make sure you close it up. Now I do kind of have this little odd one right here, and I'm going to right click and say OK. So I have my spline here, and let's see if I can go in and adjust that point a little bit. There we go, gets it right there. So now it looks a little better, and I actually missed a point down here, which, yeah, you see what I didn't want to happen is I didn't want this to cross over. So I still have, well, actually I missed a point right there that I should have put in. All right, but anyway, get the point here. I'm going to finish sketch, and I'm going to extrude, and as I said, and we got a problem with our, close loop. There we go. That's what I want to do. All right, it's been successfully closed. So now I can pick that, and I can say on 3D model, extrude. Oops, going to do that again. All right, we do want to close loop. Finish, yes, it's successfully closed. Oh, finish sketch. It probably doesn't like it because of the crossover there. All right. Once I get that fixed, what I'm going to do is I'm going to pick this and extrude it to a length of 4 inches and not more than 4 inches. That way my airfoil will fit in the wind tunnel and won't generate a lot of turbulence on the sides. Then you'll save that. We'll probably have a place for you to put that in Canvas so we can locate that, and you can turn that into me. You definitely want to put the printouts in your journal. And then once we get our 3D printer, or we have another option to create this with foam cutter, and you can create a model of your airplane wing, and we will test that and compare that data with the data that you got in the foil simulator online. Fairly simple process. As with anything with Inventor, there's a lot involved, and so you can see here where I messed that point up and created a problem for myself, but if that were fixed, it would be able to create a nice little wing that you could look at.